Welcome back, and in this video we're going to be talking about how do we solve linear systems by substitution. And we're going to focus on this video on solving a system of two equations with two variables by the substitution method. So we're going to work through the system that you see here using a four-step method, and we're going to work through it as we talk about the steps. So the very first step is we want to solve for one of the variables in one of the equations. So notice that there are two equations here, top equation, bottom equation, and both of these equations have two variables, an x and a y in them. So we can solve for the x in the top, the y in the top, the x in the bottom, or the y in the bottom. None of those are wrong choices. But there's a smart choice and a not so smart choice. Okay, so let's talk about that for a second. Let's consider isolating the x in the first equation. Okay, if we do that, we would first subtract 4y on both sides and get 3x is equal to negative 4 minus 4y. And then we would divide out the 3 to isolate the x, and we would end up with this negative 4 minus 4y over 3, which is, there's nothing wrong with that, except it's full of fractions. And for those of you who love fractions, I would go ahead and continue if you choose to. But I know many of you don't really enjoy working with fractions, and so let's try another alternative. So let's try this y. Let's solve for the y in the first equation. So if we are isolating this y, we would first subtract 3x on both sides, and then we would divide out the 4 on both sides. And so we would end up with negative 4 minus 3x all divided by 4. And again, there's nothing wrong with this except that it's just full of fractions. So let's check a different alternative. Let's check this x in the second equation. Now, if we solve for this x, we only have one thing we need to do, and that is moving this 2y to the other side by subtracting it on both sides. And we would end up with x is equal to 2 minus 2y, and there are no fractions there at all. And so if you have this opportunity, you are going to want to choose a variable to solve for that has a coefficient of 1. Okay, and this will minimize your work with fractions. So let's go back to that x. We decided that that was equal to 2 minus 2y. So the second step here then is to substitute that expression into the other equation. So we derived this expression from this equation, and we're going to sub it into this equation. So here's the equation we want to substitute it into. We're going to take this 2 minus 2y and sub it right here for the x. All right, and so let's go ahead and replace that x with 2 minus 2y. And now we have an equation that is only in y. We have substituted and gotten rid of all the x's. So we can go ahead and solve this linear equation by first distributing. So we would end up with 6 minus 6y plus 4y is equal to negative 4. And then combine all of our terms with variables on the left and all our constants on the right. We would end up next with negative 2y is equal to negative 10. And when we divide out that negative 2, we would end up with y is equal to 5. Okay, so we are halfway home. We've gotten part of the coordinates of a point, and we want the x coordinate as well. So in order to find that x coordinate, we're going to take this y value that we solved for, and we're going to sub it back into the equation we found in step 2. So we're going to take it and sub it right back in right there. And so we're going to replace this y with 5, and we're going to get x is equal to 2 minus 2 times 5, which is also known as negative 8. So we think that our solution is negative 8 comma 5. So let us do the fourth step, and we want to check our solution by substituting our x and y values into both of the original equations and just verifying that it works. So if I sub that negative 8, positive 5 into the first equation, right here for x is negative 8 and here for y is equal to 5, we end up with 3 times negative 8 plus 4 times 5 is equal to negative 4. We want to see if that is true. This, of course, is negative 24 plus 20. So we end up with negative 4 is equal to negative 4, which does work. So that negative 8, 5 does satisfy the top equation. We're going to do the same thing with the bottom equation. So negative 8 plus 2 times 5, we want to know, is that equal to 2? So we have negative 8 plus 10, also known as 2. So we do get a 2 equals 2, and that also satisfies the equation. So we can confidently say that negative 8, 5 is the solution to this system. So now it's your turn to try. Pause the video and use or take a second to try solving this system using the substitution method. And when you're ready, I will work through this system and we can double check your work. Make sure that you got it right. So go ahead and pause and come back when you're ready. Okay, let's see how you did. Like we could before, we could solve for this x in the top or this y in the top or this x in the bottom or this y in the bottom. But we are going to be smart and solve for this x in the bottom. Now be careful that you solve for x and not negative x. So if you solve for x, you should end up with x is equal to 6y minus 8. And when we sub that into the top equation, we get 2 times 6y minus 8 plus 5y is equal to 1. Go ahead and use distribution. 12y minus 16 plus 5y is equal to 1. Combine your like terms on the left and move your constant to the right. 17y is equal to 17, and y is equal to 1. Take that value and sub it back into your x expression. So x is equal to 6 times 1 minus 8, also known as negative 2. So we think our solution is negative 2, 1. We will double check and make sure that it works in both equations, and we are good. Okay, the next video we'll talk about using elimination to solve a system of equations. I'll see you there.